In this video, we'll be looking at Chapter 11, Section E.2 on compound events, and more specifically, we'll be looking at dependent events. Let's look at the example where we have 4 red marbles and 2 green marbles in a cup. Let's say that one marble is removed at random and set aside, and then a second marble is drawn, and we want to find the probability of the second marble being red. Now there are 2 scenarios we consider. The first marble that we remove could be green, and that will affect the probability of the second marble. So if the first marble is green, then the probability of drawing a red second marble becomes 4 out of 5. However, we could also consider the case where the first marble drawn is a red marble, and that also has an effect on the probability of the second marble. We can see in this case that the probability of the second marble being red is 3 out of 5. Because we're setting the marble aside, these 2 events are dependent. In other words, the first event has an effect on the second event, and we need to consider that when calculating probabilities. So let's recap what we learned in the first slide. Dependent events are events for which the occurrence of one event does affect the occurrence of the other event. Now we can still calculate the probability of these compound events using a formula similar to that of independent events. And it looks something like this. The probability of P and B occurring for dependent events is the probability of A occurring times the probability of B occurring, given that A has already occurred. Let's take a look at another example. In this example, we have a box of 4 blue buttons and 3 yellow buttons. And 2 buttons are randomly selected without replacement. That means the first is set aside and not put back into the mix. So this is an example of dependent events. We're asked to find the probability that both are yellow, given that the first button is yellow and set aside. So the probability of drawing a yellow button first times the probability of drawing a yellow button given that the first is yellow looks like this. We have, for the first probability, 3 out of 7, but then we remove a yellow button, and now the probability of drawing a second yellow button is only 2 out of 6. And when we do the math here, the multiplication, we get 1/7. Now let's put that button back, and now we want to look at the case where the first button is yellow and the second button is blue, again given that the first button is yellow. So we have the probability of drawing a yellow button times the probability of a blue button given that the first is yellow. So this problem starts out very much the same. We have 3 out of 7 buttons are yellow. We take 1 out. And now the probability of drawing a blue button is 4 out of 6. And when we multiply these 2 together, we get 2/7.